Today we're going to be working in Module 4. Module 4 is going to be about us doing some 3D work, playing around with a little bit of 3D work, but we're also going to be making a two setup part. And so what you can see on the screen is that we've got, on the left hand side, we've got our PDF already kind of sketched out here for Module 4. This will be for just the video, not for the assignment. 2x2 square block. It's going to be 6061 aluminum. It is 880 here, 1 inch to the center of this radius, and another ½ inch taller for that for the radius. And so what we've got is just really this. Maybe it's a button die, some type of forming tool. Maybe sits into a 2-inch square pocket and does some shaping. What we're going to be making it out of is aluminum, but if this were some type of button die or some type of form, it'd be something D2, S7, could even be a roller. Probably not with this square shape, but so it doesn't really matter what it is. What we're going to do is we're going to build this thing using two setups, same drawing that we're going to make both setups in. So first setup is going to be essentially what you see on the right hand side. It's the square part. We'll take a piece that's already existing, 2-inch by 2-inch square. Maybe we'll run a quick zip around the outside of it, face mill pass. Go ahead and drill and tap these holes, or I'm sorry, just drill these through holes, 1/4 inch through holes. We need to go ahead and put the text in on the back side of this thing, and then we can do a second operation. The second operation will include making this shape on the back side. Now there's a couple different ways that we can come about making that form or shape on there. Drawing wise should be pretty straightforward. Second side of it, as far as manufacturing, should still be pretty straightforward, but we can play around with just a couple of different ways to rough that thing in, maybe some best practices and just some options of doing that thing. So what I want to focus on today is really two setups. So creating two setups within the same drawing, and then also working on this 3D shape, just kind of being all curvy on top. All right, so what I'm going to do is I'm just going to get this guy out of here. I'm just going to start a new drawing. Let's see what I want to do. All right, and I'm going to go ahead and go in and I want to put it in my module, or my 134. And I'm going to call it Module 4 Video, and we will save it in Module 4. That way we don't confuse it with anything else. Alright, so here we are. We're going to start out just going on top. And so now it's kind of, that's probably not maybe the best way to start out. I probably could have started out something this way, but that's okay. We can change it as we go. It'll make drawing just a little bit easier. So square this thing back up again and zoom in and pan down just a little bit over here. Okay. I'm going to go ahead and make the shape of this part. I'll pull my PDF back up so I can put it over here on the other screen so I can remember exactly what I did. And alright, so I'm going to go ahead and start creating my sketch. And it looks like from here we've got about a ½ inch radius. We're going to go from here to here with that guy, and so this other diameter is 1.6, and it goes back, let's see, let's take a line back here from the center of this point. We go back 1 inch, 1 inch will put us right there. Okay, just get ourselves some shape here, and we need to come up a little bit, and we need to get our 1.6, so we need to go up 8, and that is 0.88 on that, and then we'll just go tab, and we'll go 90 degrees. Okay, so we got that. We can just come straight down from there. Just bring a line down here, and we can just trim that out as we go. At this point, I'll probably need to go ahead and extend out a line, extend this line out to here, and then I'll probably just trim away a couple pieces, unnecessary components. Pretty sloppy on the drawing right here. I could trim this and this as well. Now I think I've got a 300 thousandths fillet that goes in right here, and it's going to be 0.3, get a little bit bigger, there we go, bring that in just a smidge. Okay, and I got a 100 thousandths fillet that goes around the outside edge here, so here we go, put this here. Whoop. Nope, get that thing on there. Alright, so that is going to be my first part of this thing. And maybe, I think I'm off just a little bit here. I started looking at one thing and started working on another. Let's see, let's go back and double check a couple things and make sure that we're jiving right. So from here to here is 1 inch, yes, and that makes that 880. Overall height is there, and then we are ½ inch from here. Yeah, so we're good. Okay, just taking a look at two different things that I had going just to make sure that we're still staying with it. I have not drawn my square on there yet, so what I'm going to do is I think I'm going to go ahead and finish this sketch, and then I'm going to do a revolve, and so it's already highlighted my profile. I just need to select the axis that I want to do my revolve from, my revolution from, and so that takes care of this part of it. Hit OK. I'm going to go ahead and do a quick save, take care of saving that part. Something looks a little bit off here. So if you look back at my original, I've got this curvature here, and then I've got this radius here, and then I've got another radius, and if we put, if we pull the other one back up, the curvature is not quite the same. So that means I've got some kind of, so I got something janky going along here. So I'm going to go back into my drawing, and I've got a dimension off somewhere, and I've got my ½ inch radius, so let's just put a couple dimensions here to see what we got going on here. So we've got our ½ inch radius here. Yeah, so too many dimensions on it is going to start to constrain it, or beyond the constraints that it's already got. So it's already got this ½ inch right here. So if we take it out, then we make ourselves good again. So we'll take this out, delete it. Now we can probably put this dimension here and probably be okay with it. Yeah. Okay. So I've got a 300 thousandths dimension there, but I've got a little bit more curvature in this area. So what that's telling me is that my section right here must not be 880. Let's pull this back up here. So this section cannot be 880. So what we're going to need to do is we're going to need to kind of back figure some portions just so we can get this section stuck back in there and get it in there right. Okay, so I don't have that on the print for that dimension for there, so I need to figure out what I've got going on in order to make that section come back in. So I'm going to take this dimension out, and I think I'm going to go ahead and just take this out as well. Just pull these two guys out of here. I really don't need this either. So I will put a line from here to here, and we'll go up straight from there, hit escape to finish the, to stop that line. We'll go over and extend this line to here, and then we no longer need that. Delete that thing out. Oh, let's see. No, let's, instead of deleting that, let's just move it. Or put another line in here. And let's say that that 300 thousandths fillet is 90 degrees. So I'm just going to move that 300 back. And then I'm going to come back out, kind of doing a little bit of extra work here. Bring this out. So let's just put a line here to here. And then let's put our fillet of 300 in here. 0.3. That looks better. So now we've got a line that we can run across here. And then we can put our radius of 100 there. That looks a lot better. So just out of curiosity, what's that put us? So just from the center to there to there. 613. So somewhere around 5/8 would be up here probably. Okay, I like that a little bit better. I think that that should look better. Should look more like our original drawing. Yeah, now we're talking. Now we got apples to apples. Let's see, let's go back, just do a quick double check. Yep. So we get up in there. So you got from 90 degree point, center point, you start that 300 thousandths radius, and then you come in here and you got that 100 thousandths radius. Okay, so now here is our drawing zoomed up, and what we don't have is the square on the back side. So what we'll do is we'll start a new drawing. And we're going to take it, let's get this thing to fit back in here. Sucker zoomed out on me. I want to take it from the back side. And so my new drawing is going to start from here. Let's see. I need to start a second sketch, so I'm going to delete this out. Come back over here and do a new sketch, and it's going to be we're going to go from, so we can still take it from the top if we want to, but I think what we'll do is we'll take it off of this face here. Okay, I'm going to flip it around backwards, and I'm going to straighten it up, rotate it around one more time, and then I'm going to make a 2-inch square on the back side. So we'll go to tab 2, and that takes care of both of our dimensions. We need to get it centered up to that circle. From here to here will be 1. That should put us in the middle. We'll double check that by adding another dimension here. So from here to here is 1 as well. Okay, so finish that sketch. Uh-oh, we need to push that thing back. It's on the wrong side of that thing. Alright, so let's do this instead. There we go. Now we're where we want. Okay, put that back up there. I'm gonna go ahead and delete this guy. actually, I'm going to delete that guy right here. And we're going to just go ahead and work off of this one here. See if that puts it on the same plane. There we go. Now we're back in the right plane of what we want to do. Finish that sketch. Now we can go back and delete this guy out. Okay. So there we are. Now we're in the right spot. Go ahead and extrude that thing. We're going to go out 880 on that extrusion. Now, you do end up getting that gap where you've got a hole in the middle of it, because what you've done is you've got that existing one, and then we just put that other part in it, and so we'll go ahead and grab that part as well so that we can get all of that out instead of having two separate things on each other. Okay, and so now we've got our little die. Go ahead and do a quick save. All right. You know, it'd be nice to have a little radius down here in the corner, but the original drawing does not have that. Okay, so I want to go back to. I want to put some holes on the back side of this thing over here. So go back to the left, rotate it around just to get back up, and we're going to go ahead and put a couple holes in it. Put 4 holes in it. Let's put a hole here. This hole will be in diameter 1/4 inch, and it's going to be a 1.5 spacing, so we're going to go 1/4 inch and 1/4 inch in. So 0.25 and 0.25, and that, let's see, it needs to go through, so it's got to go 0.88, takes us all the way through. Let's double check that we're all the way through. Yep, got a hole all the way through on that thing. And okay, and so I want 4 of them, but I want them to all work together. So I'm going to go do a grid, and I'm going to select the object. Okay, and the direction that I'm going to go. Slide that down a little bit more. Okay. The direction I'm going to go. I want to do is I want to do 2 going across there, and the distance is going to be 1.5, and then down I'm going to go 2 holes, and I'm going to go 1.5, and that should end up with a decent grid of holes. And let's see what they look like. There we go. And so we've got 4 holes in there now. Match up. Everything looks pretty good. All right, so what we need now, so we've got our block, but we need some text on there. And so if you go back to my original one, rotate it around. Where was it? I've got SFCC Precision Machine Technology, and then the part number. And then I've spaced those out. Just kind of centering them up on the back side, and we'll center those up just like we have them. So we'll go back to our drawing, and we'll straighten it up here, and we'll come in and just add some text into that. All right. So we'll work off of this guy here, and we'll just add text like this. We'll start, work off of the grid. I'm going to change my height to 0.1, and I think the first one said SFCC Precision Machine that's not the same. Okay, SFCC Precision Machine Technology is the second line. So I'm gonna go back in and change that. So just double click on it. Just go back over there. Precision, and gosh, I feel like that could be a little bit bigger on the font, but I'll leave it alone for right now. If we need to change it, we can. We'll go ahead and do a second line of text there. Let's see. Back to the 100. Okay. That, and one final line. We're going to pull that down just a little bit lower. And maybe we can go with a little bit higher on that text just to see part number. And 3, 4, 5, 6, 7. How about that? That looks pretty good. A little bit. It's probably too big. Let's go ahead and move back down to 100. Yeah, I could probably go up just a little bit more just to kind of keep it in line with the rest of it. And hit OK. Alright, so all we need to do is make sure that that is pretty well, it's not completely centered, but it would be readable, and we don't really have dimensions for where that goes, so we'll hit Finish Sketch, and then we will save it on there. So we've got something similar on that. This one's probably a little bit better spaced out. So here we have our etching or engraving on the back side. That's going to be our first side of our part. Okay. So we've saved, and so now we're ready to go into manufacture. And so we're going to go ahead and start setup on this part. Now, if you'll notice, XYZ is all in a janky, wonky place, and so we do want to take a shot all the way around this thing. So we want to mill around the outside when we want to do a face mill pass across the top. X0, Y0 is going to be the thing that we need to work out first, and so I would put this part probably at the middle of it if I could, or go to one corner. And so I think you could do something like that. That would not be too terribly bad. This is going to be the top of the stock. Okay, so the only danger in taking the top of the stock is that you kind of have to remember where everything is at. So one thing that we can do is go ahead and go into a selection of where we really want that thing to be at, and let's go back and change around a couple things here. I want my X0, Y0, Z0 to be now I'm on the actual physical part itself, okay? And so that helps making this face, this machine face 0, and then all my engraving would be down from the actual finished face of that. Now what I've got to do is I've got to flip some things back around so I can get my Z-axis in the right direction. So Z, and that would be correct. So I'll look at my part, and I need to change my Y. So let's flip the X. Actually, let's do this. Let's do Z and Y. There we go. That looks a lot better. So that stuff can be avoided by just really kind of starting out with a little bit better setup. And sometimes I would say I think you can kind of start to play with it and mess around. Sometimes you're going to be given a drawing that somebody else created, and then you're going to need to work off of it. So you need to know how to be able to move these around and change them to the places that you want. Okay. We've got our X0, Y0, Z0 on the center of the part, on the top of the finished edge. So that means when we set our work offset, we're going to come in and find the center of this part, and then we're going to either probe it or use a 1, 2, 3 block, come off the top with the spindle. We're going to need to come down a little bit more with the offset for Z. And let's say that we've got, instead of 40 going around it, let's just say we got 50. Just I realize that those are insignificant numbers, but it'll help me at least. I think 50 is a little more rounded than 40. Okay, I'm looking at my part. I feel like it's okay. I guess I'm a little unhappy with these numbers down here. 2.1 by 2.1, and then the Z of 2.43. I can live with that. Again, at this point, it's not going to matter. It doesn't matter how big we make the part. We could say stock size would be around the outside of it is 75 thousandths, or you know, like I guess we could make it 100 thousandths around the outside of it, or 125 around it. That would make it a little more of a nominal size of stock, 2 1/4 by 2 1/4. And then let's see, we could go with a little bit of a bottom offset of 70, and that would make it a 2.5 part. And the only reason that I'm doing that is just because I'm trying to keep some numbers even for if we were making this part, just for ordering of material and saw cut, kind of trying to stay into some of those nominal numbers. Okay, so I've got this set up ready to go, and I hit OK. So I'm going to go ahead and go in and call this setup 1, and this is going to be my setup 1 milling base. How about that? Okay, so there's my setup 1 milling base, and I will go ahead and use, let's go back in there. I need to do something real quick. So one of the things that kind of drives me crazy about this program is on our work coordinate system, 1 I believe is 54, 0 is 54 as well. Now, like if 0 is 54 and 1 is 54, then it just makes sense to go ahead and leave it at 0. But whenever you go to post process, sometimes that's going to cause some type of error, or at least a note, and we'll try to eliminate as many of those notes, errors, and pieces as possible. Okay, so we'll go ahead and complete our first setup on this whole part. And so what we want to do is we want to mill around the outside. We have to have an end mill that'll stretch at least 1 inch depth of cut going around this part. And then we need to bring in probably a 3-inch face mill, and then I think we can probably just 1/4 inch drill these things. Doesn't call out any kind of chamfer on it, and so if we were to need to chamfer it, we could always hit it with the cordless for the outside, or just to get those chamfer to break those edges. You could use a whirly bird or anything else that you wanted. What we're concerned about right now is milling around the outside, face milling it, drilling these holes, and then doing some engraving on this part. All right, so we've saved it up. We'll go ahead and go around the we'll go ahead and face mill it real quick. By now you should have started to build a little bit of a tool library. So you want to pull from that, and so I'm going to use my 3-inch Kennametal face mill, and I'm going to come in. I've already got some RPMs and stuff set up, but probably a little slow for what we've got, but it'll be fine. We're going to mill this face, and I think I'm okay with everything else here. probably change my extension. Let's go 1.6 beyond. That'll just get that part going through there. And let's see what it looks like. Okay. So I'm going to face it off. And now I want to mill around the outside perimeter of it. So do a quick save. I'm going to do a contour around the outside. I want to go down to the bottom of it whenever I do that. So choose my next tool. So I want to go ahead and start thinking about the tools that I'm using for this part. On the second side, I'm going to use, I've got a 3/4 inch end mill that's got a 40 thousandths radius on it, and that's what I'm gonna rough out the other side with. But I'm also going to use it to finish this. So it is a it's 3/4 inch in diameter, and it's got more than a full length of 1 inch of cut on it. So let's see, the overall length on it is 3.15, and let's see, it says here it's a 2 flute. I actually think it's a 4 flute carbide end mill. So we need to probably go, oh, I've already got carbide selected. We do need to go ahead and do a quick modification to that thing. So we're going to edit this tool. We'll also need to change tool numbers on it. So it's a 4 flute. Let's see, flute length is not 40 thousandths. The tool nose radius is 40 thousandths. I think length of cut is like, let's say it's at least 1.25 inches. 2 inch to the shoulder, probably more like 1 3/4 on the length on it. Body length is about 3 inches. So we're just going to say, we're going to just call body length and shoulder length at 3 inches. I don't want this thing sticking out too far. I don't want someone to see that and let it stick out too far. Okay, so we are in inches. We are 4 flutes. I don't know holder positions yet. So we're going to go ahead and, that's actually, pretty sure that's a Kennametal. We're going to call it Kennametal ML. Okay, and I'm going to select that thing. And then we're just going to go, we're going to select our contour. Come down to the bottom of this thing. It's already selected to go around it left to right. Now what I want to do here is I want to go ahead and bring this thing down. The bottom of it is going to be, I want to go down just a little bit lower than it. So I want to go down, oh, maybe 100 thousandths lower than what we're going to run. Nope, that's 10 thousandths lower. And so let's see the bottom height. I'm going to go ahead and go into selection. Bottom of the cut should be down. Let's back up from that. Did not mean to back up quite that far. Already edited that. It's good. Go back, select our cut, and then let's see what that looks like now, and then we'll go from there. Okay, so like I say, I want to go down lower, because what I don't want to do is come up with a possibility of leaving a really thin edge there. So I'm going to go in, change that, and I want to go down below it. Get this thing straightened up. so let's go down. Let's go minus 50. See what that looks like. 50 should take care of it. And so all I did was just give myself an extra 50 thousandths to take that down. So I'm going to say, according to my print, that is really doesn't have, or it's really got a ton of tolerance on it. But in my mind, I'm thinking that's probably not going to work out really well, because even though the part itself is 2-inch square, and it doesn't necessarily call out any type of critical tolerance according to the PDF on this thing, I probably want to set my second operation as a set of soft jaws or some type of fixture, toe clamp, nesting into a corner, so that I can get some repeatability off of it. So even though this square of 2-inch by 2-inch is not critical, I need to treat it as critical. So what I'm going to do is I'm going to come in and I'm actually just going to duplicate this. So I just come in and I right click and I duplicate it. And so I'm going to come back up to this first one. And I'm going to go in and do a quick stock to leave. And I want to leave nothing axial, just for Z. I want to leave about 10 thousandths for around the outside of it, okay? And so that's going to give me then 2 passes. And so you can see that pass is a little bit further out than this pass, okay? Let's see, so let's do this. Let's go ahead and let's go from the top, and we'll just check this part out, see what it looks like up until this point. So we've got a square. We're just going to say that's 2 1/4 by 2 1/4, and we'll speed this thing up just a little bit. We got our face mill. We're going to go around the outside of it. Okay. We are left with a little overlap here. So you can see this is the corner radius in there. So since we've got a 40 thousandths corner radius, and we've got, I'm going to back this up into medium. We've got 50 thousandths. It's only going to leave us about 10 thousandths. I'm probably going to go back in and do some changing on that. So instead of 50, I'm going to go ahead and go back. I think originally I'd said 100. I'm going to go back to that 100, and I'm going to do that again over here to make sure that that matches. I'm going to go ahead and just take this off and go back to standard for that. There we go. So now I'm really getting about 60 thousandths of solid sidewall from that section. So I get this corner radius of 40, but all that's going to be long gone by the time I'm finished with my part. Okay. So the only thing I have left to do now is to take this part, do a quick save. Here my computer is starting to wind up. And I need to go ahead and do some engraving. And so I'll hit my engrave. And I need to select a tool. Now for your engraving, you'll want to make a tool. I think you could either create or use something that was already a spot drill. I think you can do it with a small spot drill. I also think that you could do it with a really small ball end mill, and it would look really nice. And so what I'm going to do is I think I'm going to go in and just I've got a ball end mill already that's 3/8 in diameter. Trying to see if I've got one already set up that's something close to that. It doesn't look like I do. So I've got this 3/8 ball. I'm going to go in and duplicate it. And I'm going to edit it. I'm going to change it up some. And so I'm going to call this a 1/16. So 1/16 ball. And I'm really not even sure that that's going to be great to use. So I think on that, I think it's got an 1/8 inch shank on it. Let's say it's 1 inch, and let's say I got a flute length of maybe a 1/2 inch, probably not even that much. Overall body length is probably 1.25. So that means the shoulder length is probably not that long. So shoulder length is probably 0.75, if that. Okay. Now it is a carbide, so we got a 3 fluter. Let's look at speeds and feeds on this. On something like this, it's so small, and carbide 3 flute can't really go too fast on it. Chip load will pull down to 2000s. And let's go on up to, let's say 8,000 on our RPM. Okay, so we've got it sitting as tool 6. We'll leave that for now. Probably need to go in and do some changing on it. So that one takes care of that. And now we need to figure out what we want to engrave. It's really kind of a big tool for our engraving. That's what my real hesitation is in here. It's got that 1/16 in diameter, and you're just not going to be able to go very deep with it. Now, if you use something that was a little more sharp, 90-degree spot drill or something like that, you're probably going to get something that looks a little cleaner on that. I could increase the text size on that. That would help on that part. Okay, so let's go ahead and go in and see where we're at. Alright, so something doesn't want to move here. So I've selected the tool, but I can do, let's just hit OK from there. Okay, so we must have been stuck in something. All right, so we've got our tool selected. We'll go ahead and select our contour, our words that we want to engrave, and let's add. I think I grabbed that line right there, so let's back out of that. And so I'm going to select these 3 lines of text, 1, 2, and 3. And let's see what it would look like from there. So my tool itself is going to give me just a little bit of problem, so I'm going to need to go in and find something different or create something different. So let's go back in, and instead of using that thing, we'd still use this tool, or we could duplicate a new tool. So let's just duplicate this guy. We're just going to change it while we're here. We'll edit it, and we're gonna keep the same diameter of this thing. We're just going to say that we've got a really small spot. Let's actually do this instead. Engraving. This is the only thing that this thing would be used for. And so what I'm going to do is I'm going to change this to see if I've already got an option for something that is an engraving tool. I have a chamfer mill, I have a center drill, I have a spot drill. Now if I use a center drill, that's pretty small. It's got a lot of other options on here. We could definitely use it, probably just for ease of just popping numbers in there. If we go to our spot drill, it'll be a little bit simpler on our choice. And so I don't have one of these, but we'll need to find one of these. We'll change this to 90 degrees, and see, our diameter is the same. We'll call it still 16. And let's see if we don't. See what that thing will look like for us. There we go. Now we can get in. That was really my fear of using that ball in there is just, I mean, we've got a really small 100,000ths on our text height. It's pretty small. So let's run this thing through full. Oh, actually, before we do that, let's save it. And then we will go back and run it through graphics. Speed this thing up a little bit. Okay, that looks pretty good. Now, one thing I probably should have done sooner. Engraving's typically my last thing. And we can still take care of that as we go. We'll go ahead and do our holes. So I did hole recognition, and I've got a spot drill, and so what I want to do is I want to just change that to just drilling. I don't want to spot drill that hole. Okay, so on my, if I come in here and I do spot drill and drill, it's going to go ahead and automatically pull up a spot drill. Now if I go in and do a simple drill, I might be able to just get the drilling itself. Let's see what we get. So we just gotta wait for a second down here at the bottom. We've got that still generating. Once we've created that, we can come in here, and so still it came in, and so I end up having to redo. I got to come back in and do some modifications. That I don't want to spot drill it, so I'm going to delete the spot drill out of it. And by using that simple drill cycle, my suspicion is when I come in here, probably I'm not peck drilling. Drilling, and so I'm just going to do a G81, just drill in, drill out, which is probably okay on this part. I mean, we're talking about an inch, but it is only a 1/4 inch in diameter. So I want to go ahead and do a deep hole drilling, full retract. And let's peck down 100,000ths at a time. And no dwelling. Pretty okay with everything else. I don't know if I already had a 1/4 inch drill available to use or not, but so I'm just barely going through there, and that should be okay, but let's see if we can't go in there and make our drill just a little bit deeper, just to give ourselves a little bit of safety on that. Yeah, let's go down about 50,000ths through that. All of that area gets cut away on our second operation anyway, so it shouldn't be a problem. So if we look, we've got tool 1, we've got tool 8 running 2 times at the rough and a finish, then we've got a 6 for engraving, and then we've got our 3 for our drilling of our hole. Now, if I want to change some things around, and I probably will, I want to go in and do, I want to edit this tool. That's our face mill, and I'm going to change it to tool 2. I'm going to change this one, edit tool, and I'm going to change it to tool 3. Changed both of those. I'm going to go ahead and move this guy up above that. So all I do is hold down on my left button, move it, and so really it doesn't really matter where that part is, but we can go ahead and move it up there too. I've got a 2 and a 3, and this drill, we'll go ahead and edit that tool. We'll make it 4. Let's take a look at it while we're here anyways. This is one that I did not have set up. It's just one that the machine picked for me. I think I'm just going to go ahead and I'm going to leave it for a second, and I'm just going to come in and do some changing on it. So this is 2, 3. This will be 4, and we'll make this guy 5. That's one that we created. And so we will post processor, go to 5, and go back to that. I want to go back to my 1/4" drill and make some adjustments in it. I just want to choose a different tool for that. So I'm just going to go in and edit. Go back over here. See if I've already got a 1/4" drill set up in my options. I got a 1/4" flat end mill. I do not have a 1/4" drill, so we'll go back to the one that we're working with. And here we picked a 1/4" drill. It's not going to be able to be tool 3, so let's go back in there. And let's hit OK, and we're going to go back and cancel that, and then we'll come back up here, and then we'll edit the tool. Call it tool 4. Go back over here, and it is going to be a 2 flute, and let's say it's not a carbide. Let's say it's probably going to be just a regular high-speed steel drill. Probably go down just a little bit more in my RPM, somewhere around the 4,000. I have not yet calculated my speeds and feeds for that, but you can do that on your own. We'll give it a 5,000 chip load though. Okay, now we'll go through there, and we're okay with that. So now I've got a bunch of tools that no longer function because I've got all these circles with the exclamation point in them. And so if I do a Control G, should be able to fix all of those together at the same time. Oh, I did not have them all highlighted, but let's see. Oh, missing the model. So let's go back, and I'm going to click here and just I'm going to fix all those, and Control G, got those taken care of. All of those are probably just going to be the same thing of not having the model attached to them, so we can go back in and do that if we want to. Edit that. Go back here. Let's see. Not seeing it. I see the chain, but I don't see the model attached to it. It's okay. Let's go ahead and do a quick run through. Speed that up a little bit. Okay, that looks pretty good for the bottom side of that. It would probably be a good idea to just zip around it with not necessarily this tool, but another tool just to break those edges off of it. But for what we have, we're okay. All right, so we'll do a quick save. And so what we need now is to create a new setup. So we have setup 1, milling the base. So let's say we've completed this operation, or all these operations on these parts, or maybe we've got it going in a multi-stage fixture. This part could just be dropped into a vise, 2 1/4" material, mill around the outside of it, face mill it, drill the holes, and engrave it. And then maybe we go to a fixture or a soft jaw operation for the second side. And so what we're going to do is we're going to go back into setup. And then we'll create a second setup, and so you see it automatically creates setup 2, and so our setup 2 is going to be flipped over here, and I want it to be on the finished part right there on the top of that. Let me move it down here a little bit, rotate it around so you can see it. So not the top of the stock, but on the top of the finished part of it. So I'm gonna go right there. For where am I gonna put my X0Y0Z0? So I've got it on top, but if you notice, my orientation for X, Y, and Z are not correct. So I'm gonna go ahead and go in and change my, let's change my Z and my X. So first my Z is going to travel in this direction. I will flip Z, and then, let's see, how do I want this thing to set? Flip it over here, and I'm going to go ahead and change Y or X. My X axis is going this way, and I want to flip the X. There we go. That's probably how I will run that part. So now I've got my X0Y0Z0 sitting on top of my part. Right, flip it over, and so there I have that. And my stock. By now my part is 2x2, so I've got no side offset. So I go to 0 on that. And then I think we had said on the bottom we had 70 thousandths or so. We don't really have a ton anymore. We milled off some off the bottom side. That was 50 on the bottom side. Essentially for this part, it really isn't going to make a whole lot of difference, but we'll go ahead and change it to, let's see, what do we probably have? Do we have 50 on the bottom side? Actually, we must have 70 on the bottom side at 450. So we had 2¼ by 2¼ by 2½. We milled off 50 thousandths off the top side. That leaves us with a block that was 450, and then that stock offset would be 70 thousandths on that top side. So that's what's coming off of the top there. Okay. Now for our work offset, we're going to be in work offset 2 for our second operation. And that should be then G55 for our offset. Okay, and so that's going to be that part of it. And so if we want to change this, we just leave that at setup 2, or move that to setup 2, and we call this the milling the form. Okay, so on this part, picture yourself with this part sitting in there, and it is going to it's got vice jaws or some type of fixture it's setting down in below here. You've got your holes and you've got all of your other pieces in there, and so we're going to need to mill around the outside of it, and then we're going to need to mill this section here. And so what we want to do is we're going to bring back in that 3/4 inch tool, which is tool 3 that we did our 2D contour with. We're going to rough this entire shape out. And so I want to play with that just a little bit. And so I think we'll come in and we'll try to do some adaptive. And we're going to select that tool. It's already got tool 3 called up. We're going to use it. It's going to be awesome. And we do not want to mill the entire thing, but we want to mill a lot of this thing. So I just want to change how far down I go with it. And so I want to go from this selection, and sometimes I have a hard time grabbing that, so I'll catch the hole. And let's just see what this thing is going to look like. I do want to leave a little bit of material on it as I go around it. Let's just see what we end up getting from this part. All right, so that's pretty slick, I believe. So here we have a roughing out of it. Let's take a look at what it looks like graphically. Okay, that looks pretty good. Obviously, it probably won't go quite that well, but it's still tool 3. It's adaptive. Let's go in and take a look at some of the details on that thing. So we're spending about 5,000 RPM. We've got about a 4,000, just over 4,000 chip load on that thing. We're not going to go down any further than what we've got at this face. Okay, that helps to be able to kind of trap some of that stuff in. And so I think I want to leave. Gosh, I don't know that I want to leave quite 20,000 stock in both the axial and radial sections. I think I want to probably go to like something like 10. And then probably in Z, something like 5. And just to bring that thing down a little bit closer. Okay, so we'll stop there. Go ahead and let that generate. Looks pretty good. We'll go ahead and do a quick save from there. Now that I've got this thing roughed out, I need to come in. I need to finish this area right here, because since this tool, if you remember, has a 40 thousandths tool nose radius, I created a 40 thousandths tool nose radius down here. Now, obviously, that would be awesome to have. Strengthen this up, because this kind of becomes the break point on this part if it's to fracture. But the problem is that the print doesn't call out any kind of radius there. So you probably get away with 10 thousandths. Probably get away with 15 thousandths, 20 thousandths, maybe. But we don't know. So we want to try to bring that in just as small as we can. So we're going to come in and just do a contour around the outside of that thing. Bring it into size. Alright, so we need to come around and mill this section here with an end mill that has a minimal corner radius on that. So up until here we were at tools 2, 3, 4, and 5. We're pulling back in 3, so our next tool number would be 6 if we are running from an empty carousel or chain. So I'm going to come in, I'm going to do a contour around the outside. I'm going to pick this bottom edge right here for my contour. I need to come back up here and I'm going to select a new tool, see what I got in the library. It would really be nice to take another 3/4 inch end mill, but I don't know that I have one that would do what I want. I know that I have a 1/2 inch square end mill, and I probably have a 3/4 inch high-speed steel end mill that I could use for that. So what I think I'll do is I'll take this guy and I will just duplicate him and then come in here and then just edit it up. Okay, so this is going to be a flat end mill. It is 4 flute, and we're going to say that it's high-speed steel. Those numbers will probably still jive, so we're going to make sure that we note this as being a 3/4 inch high-speed steel end mill. Speed and feeds will definitely change. I want you to go ahead and calculate those out. Don't just use what I have. So I'll go with 5 thousandths just as I'm throwing this together here. It cannot be, or could be tool 8, but for our purposes, I think I'm going to make it tool 6. And then select and go from there. And so now I've got my tool, I've got my contour, everything else should really kind of fall into line. And let's see what it looks like. Yep, looks good. That's a good end mill to use. It should be able to grab, shouldn't leave any corners on here, but let's take a look and see just to make sure, because if it does, I want to go ahead and copy it and offset the pass on that. So let's go ahead and run that through in graphics. Okay. So what I was concerned about is if I use a small end mill, um, I will end up with a little small scallop around this outside edge. And so let's do this. Let's just say, just for demonstration purposes, we went in and selected this half-inch end mill, half-inch flat end mill. Okay, so let's just say we used it. Now, let's run that graphics. Okay, so here's what I'm talking about. What you get is the scallop left here. So the blue is what just got finished, and the green is this area that's left. So if I had a half-inch end mill and I wanted to use that, here's what I'm going to need to do. So I take this tool, and I need to go in and edit it real quick. So it's going to be tool 6. Tool 6 is the half-inch 2-flute. I did not check speeds and feeds on it, and so what I'm going to do is I'm going to duplicate it, and then I'm going to go in and do a quick edit to it, and stock to leave. I am going to leave nothing in Z, and I would leave, oh, maybe let's just see what an 1/8 inch looks like. And so what I now end up with is 2 paths going across there. So see, I've got a finished pass, and then I've got an outer pass to take care of that section. So here we are. Go back, speed this thing up, and I've just got it spinning through there pretty fast. So graphically, it's not going to look perfect. But see now, all the tan is what this tool has done, and so I can leave it like that. You know, I probably wouldn't want to try to do that. I would try to make it as big of a tool as I could. That would be better for it. So I've got that finished out now in 2 passes. I can leave that tool alone if I choose to. Go ahead and get this thing kind of pushed back into place. So my second operation is using tool 3, tool 6, and we'll do 2 pass with tool 6. So now kind of the one that I wanted to play with just a little bit was coming around here and doing some 3D on the top of this. And there's a couple of different 3D options that we can use. Probably what I would see myself using more than anything is on a situation like this. And it helps if I know what it is this whole this part's doing. It does not call out a surface finish on it, but I do assume that it is supposed to be pretty smooth and not all janky and you know, have a lot of scallops in it from the machining process. So here's what I'm going to start with. I'm going to see what this looks like. I'm going to go radial, and I'm going to need to pull something that's a ball end mill and go in here, and probably something like a 3/8 ball end mill. So I've got a 3/8 ball already set up. I'm going to use it, and I don't think that I want to leave any material on. I think I want to go ahead and just do it because I've already roughed it out. Now, I don't want to come all the way down anymore. I just want to come down to about here. And so if you notice, all I did was just pick that bottom part up and just raised it up. And so I'm blocking up how far this tool is going to go down. And so picture this ball end mill going down this profile radius. So going down this radius, then going down this radius, and going down this radius again. I can't stop it here because it won't go down its full area and get into it. So I do need to go down a little bit beyond that. So I move my bottom plane just really where I need to, or where I think I need to go, just to see where that's going to be at. And we can play with that and find out just a little bit more exact of where it is that we want to go. So if we want to go a little bit more, we could grab this as a selection, and then we could go change that offset to 0. bring that down, and then maybe make it go negative 375 deeper than that if we wanted to. It's probably way too much. So probably, so if our radius from that is 187, let's say we go down 190. Should be plenty to go through that. Okay, that should take care of that. So look at what we get. This slick looking pattern that's running across this thing. Now, one thing that you have to think about, this is a lot of movement, and it's going to take a little bit of time to do this. So let's just see what this thing looks like. Okay. So we can control our surface finish by step over, and some of the pieces that we would, some of the components for that. Speeds and feeds would definitely be doing some things there. We could definitely speed that thing up at 6,000. So we could come in and like I said, we can control how that thing runs. It could run only downhill, only uphill and downhill. We could leave some stock. We can push in some areas that'll make it cut just a little bit better if we need to. For me, I'm probably going to go ahead and run this part the first time, see what it looks like as far as surface finish, and then make adjustments from there. You know, feed per twos of 5 thousandths. I mean, you're really just rolling down that hill. And rolling up and down that hill, and it's probably going to look, gosh, I don't know. I think it could look pretty decent that way. I'd be more concerned about my step over through here. The only thing that I would probably just be sure that I would change is I'd probably change this to 8,000, and probably that's all that I would change at this point, and just leave that alone. That cannot be tool 6, so I do have to go in and edit this tool, and we'll make it tool 7. And then we need to regenerate that. So Control G will generate. You can also come in here and just right click and then generate from that as well. So what I now have is 2 setups that I can run, and I can run them individually, or I can run them together. And so when I want, here's the advantage. I always want to try and keep everything in one program, and that makes a huge difference. So that 5 years from now, when this customer calls and wants this part done again, I can call this program back up. I can go find this file in Fusion and then be able to pull it back up, and that makes a huge difference. Okay, so when I'm running my part, I don't have to run both operations at the same time. I can come in here and just select this top one. I can run it, or I can select this bottom one and run it. So I get a lot of options. I can run it all as I can run both of them if I want to. So I will go in, and I wish I would have thought of this before. Go ahead and create a couple of setups though. So let's just say that there is a, I think we said that this part was 3, 4, 5, 6, 7. So maybe I would just do 3, 4, 5. Maybe I just do 3, 4, 5, 6. And I would call this side 1. And I can preload tools or not on depending on what our machine is. It's not going to make any difference anyways. It's just going to hit grab and setup 1. And so we just said setup 1 is milling the base, and then we can go from there. And then we can create another setup. And so this is my NC program for that. And then I can go in, set up another one, and we're going to call this 3, 4, 5, 7, and we're going to call this side 2. We're going to pick our operations. This is going to be setup 2. And hit OK. And so now I have NC Program 1 and NC Program 2. From here, I can go ahead and hit post-process if I want to. Come down here, grab my NC code. I'm using 2345, and that is going to be my face mill. My 3/4 end mill with a 40 thousandths tool nose radius. I've got a 1/4 inch drill, and I've got then my engraving tool. And so this program should not be terribly long. The engraving is going to be your hard part that you're going to need to. That's going to be your long section of code. The rest of it should go pretty smoothly. Okay, so there's that, and then we go to NC Program 2, and we can post process it. Grab that thing. So we're calling up 3 again, and then 6 and 7. And now this one is just going to be really long all the way through. And so the only thing I want to double check is really work offset. Okay, so I've got not seeing a G54, 55 anything in there, so work through some of that. So probably what my problem is I did not select my machine, so I need to go back and do some work on that, make sure that I've got my right machines picked. Let's go in and edit program 1, go back, and here is my problem. I did not pick a machine. So I am going to mill. I am going to use my Haas automation, UMC 750, and then let's hit OK from there. And then the same thing here. Let's go back in and edit that. The right ones. UMC 750. Okay. Now let's just take a look at one of them, and we will post process. Yeah, we want to redo those ones that we hit. Now we look just a little bit better. So if you notice, we're now at G55. This G53 is just getting ourselves out of the way. That way, if we've got the table that needs to spin around, since this is a UMC 750, it's got those 2 extra axes that you can spin around and move where they need to. That is a pretty good program from that point. And so you've got both operations now stuck within inside of this one program. And so I can save it. And then I could use it really just however I want. So if I wanted to do 2 vice setups and run these 2 things in parallel, or I wanted to just run all of 1 and then all of 2, I can definitely do that. You want to make sure when you're posting out or when you're running some of your operations, you want to go ahead and make sure you're selecting the setup when you're running through graphics. And then here you have NC Program 1, NC Program 2. Okay, so I'm going to give you a project that is similar to this one, but it is not going to be the exact same thing. You will do the programming, drawing and programming, and I need you to, a couple of you are still having some problems doing this, you need to save your Fusion file and submit your Fusion file and your NC program to me. I'm getting a lot of 90% of you guys are doing just great on that. Everybody's giving me their NC files without any problems. So this one I have 2 NC files. But some of you guys are still having problems getting me your Fusion files. So you want to save that thing, save it to your desktop, and then submit it then through Canvas, and that'll make things go a lot easier. Because that way, if I have a question, I can get into your Fusion file and work from it and just help figure that out. Otherwise, I'm just not giving you full points for it. So anyways, take care of those things, and then this module will have the assignment that looks similar to this, and then there is going to be a second assignment with inside of this. So this is module 4, and there's going to be a and a B inside of this. So you're going to do a Titans a CNC part as well. So don't wait till Sunday to open this thing up. All right.